Hi everybody, welcome back to the final episode where I recreate the snake game. In today's episode I'm going to give our snake and environment some colors and do some final code refactoring. We now have a new terminal where we can detect the size of the screen, so let's use that instead of just using hard-coded values. This basically means that we have now an environment starting from position 1, 1 until the max x and max y that has been detected. Let's see how this works. I'm going to resize my terminal first to some strange positions, but let's disable the obstacles for now, because the obstacles were hard-coded, so we cannot use that like this. Let's see if we can reach all the way on the right of the terminal. Oh, good. Oh, perfect. Let's make it ridiculously small. And this also works. Perfect. Let's put, for example, the position of the snake to be to start from the middle. So snake will start always from the middle, going to the right. If we resize this terminal, then it should also still start from the middle and go to the right. Let's start and colorize our terminal now. So the snake, I want it to be a full block, for example. So the head of the snake should be printed with a different character, first of all. I don't want this star, I want a block. Unicode character 2588. So let's use this one here. Unicode 2588. Let's see how it looks. Yes, that's the one. Let's create a method in console to set a particular color. Set text color, and this will be a string color. And we'll have also a public method to set the background color. The color here must be one of the colors in this format from the ANSI code. When we want to print out the snake body, we'll set the color to, let's see what colors we have defined. Red. Let's try yellow. There it is. And when we leave, it's set to black. Now let's see what we do with the obstacles. What should the obstacles be? Now they look like this, they look yellow. Okay, so let's set a color for the obstacles. Let's make them red. And let's not make them axis, let's actually just make them the same full solid character, the block. Interesting, copy paste works funny. It actually transformed it into a block. Oh, there. And the food, let's see, what color should we give to the food? Make it green. I don't have a green, so let's define a green, create constant. And the green would be, let's look it up in the ANSI codes. So what was it here? Red was 31M, green would be 32. Okay. There we go. Now what I want next is to paint the background blue. We should have an initial paint method. And there we set up everything. There we set up the obstacles, the background, and so on. So maybe it's a good idea to create that now. paint initial method. Okay. But now we need to actually fill the entire screen with blue. So let's see, how do we do that? We need to have the maximum size of the screen. Let's make this variable global for now. And then we can use the get y from it. And what I'm thinking is to create strings, empty strings of get x empty spaces and write them down in a loop max y times. And ta-da! All right. Let's now do some code refactoring. I think we can do quite a bit of improvement to the code, at least to separate it and move it to different classes. For example, what I want to move is, first of all, this check event. I'd like to move it to the environment, because the environment is the one that checks for the collisions, and then this method makes more sense to be in there. Also, I would like to give the objects, the environment, the snake, and so on, I want to give them the opportunity to paint themselves. So I'm going to create a paint method in each of the objects. I think for those methods I need to pass in the console as a parameter, because I don't want to initialize those objects with the console. So let's do first this. Check event will just go to environment. And this event just delegates to environment check event. What happens here, however, is that we send back a state. We send back is running. We can make it return a class game state. Which can contain a couple of booleans, for example. Is game over, is win. So we're going to return now a game state. And we're going to have here a game over boolean. And also here boolean false true, depending on who won or if the game is over. And then we can check here in snake game the game state and then act accordingly. If game state is game over, do this, else if game state is win, do that. So this is for game over, this is for you win. Now we put this logic of check event into the environment. Good. Now let's move some of the logic with paint. For example, this paint background should be on the environment. And I don't want to set the console in the environment, so I'm just going to pass it on. Let's make this public so we can call it from a different class. Good. It compiles. It runs. It went right through the obstacle. Oh, let's see what I did. Environment. Check event. Oh, of course. Is running is false. In both states. In both cases, if the win or game over, then is running is false. So the game ends. Good. Alright, next I said this paint should be on the environment. And I should also pass the console in here. So let's take the paint event, the paint method in here and move it to the environment. And it should take a console. We have a snake here, that's fine. Don't make it private, sorry, make it public. We set colors, we paint head, obstacle, position, obstacle with body, position, right? Food, we don't need that, we have the food already. Position food, set the color, paint. Good. What we need to do here, where are we here? We are in it still compiles and hopefully still works because we didn't change any logic. We need to change the paintRemove. Now the paintRemove only talks about the snake. So let's check this. Let's actually move this paintRemove on the snake. Is growing. If it's not growing, then we get the tail. And we just print something in the tail. Now if we did this, we also can do a paint on the snake. So in environment where we paint the snake, this method could be a paint method on the snake. Where again we get the head and we write out the head in a certain position on the screen. Then we paint the obstacles. So if we did this for the snake, let's do the same for the obstacles. So we take all obstacles and for each obstacle we call paint on the obstacle. So for each obstacle in obstacles, paint the obstacle, and the same for food. If we have a food, then let's paint the food. This constructor here, it's a bit messy, so I think I'll change this one as well. Because I should just create the environment, and then the environment should create the snake and the obstacle and the food, so we don't need to control everything from the snake game. Let's get this snake and we put it in the environment constructor. Just like that. Max screen is bottom right. Indeed, we don't have a snake. That means we need to delegate it into the environment. And calculate next state also should be delegated to environment. let's just create a local variable snake equals environment. Create getter. Yes. The obstacles should also be created in the environment, so we don't need to create them here. So in the environment, we'll just say create obstacles or something here. And we're going to do it like this. That's pretty much it. Most of the methods are going to the environment to check stuff, to read stuff, or to update stuff. So that's pretty okay. All right. Doesn't look that bad after all. Well, this was an incredibly long episode. Thank you for sticking around. As usual, if you like this kind of content, please give it a like, subscribe, and ring the bell so you get a notification next time I upload a video. And until then, bye bye!